So yesterday in class we did an activity and started looking at sequences or lists of numbers with and without patterns. We generated the next terms, tried to find the 45th terms, and started to talk about how to have rules. And we also talked about the shift from x and y to n and tn, where n is going to be the ordinal or the number of terms. So the first term would be n equal to 1, second term n equal to 2, etc. And tn represents the actual terms or numbers in the pattern or list. If you weren't here yesterday, make sure you talk to someone about some of the terms that we defined and looked at. We also looked at arithmetic and geometric patterns in particular. So arithmetic patterns are when you have a sequence and there's adding or subtracting between each term, and geometric is when you have multiplying or dividing. I'm going to show you a way using a formula to come up with a way to have the general term, and so that we can generate the 1000th term without having to do the 999 before it. So we're going to do some examples. So I have a sequence that is -9, -6, -3, 0, and continues going. We want to figure out if it's arithmetic. We're going to find the common difference if it is, and then generate a formula for the general term. So to figure out if it's arithmetic, it has to be going up or down by the same amount. I look at this and I can see that my terms are getting 3 bigger each time, so I'm adding 3, so that tells me my common difference is 3. If you don't see it, you can always subtract. It's like finding first differences in grade 9, and we backward subtract. So -6 subtract -9 is +3. -3 subtract -6 is +3. 0 subtract -3 is +3. If when you do this common difference you get the same number each time, it absolutely is arithmetic, and the number you get represents that D or that common value. We talked yesterday a little bit how A is used to represent the first term in any sequence. A is the first letter of the alphabet. So for this term, I can see that for this sequence, I can see that the first term is -9. So if you know what the first term is and what the common difference is, you can generate the rule for any arithmetic sequence based on the rule Tn equals A plus n minus 1 times D. If you're confused a little bit by this T subscript n, we spoke about it in class yesterday, so make sure you talk to someone who was there. And now a general rule is always going to have Tn and n left in it. It's like our x and y in an equation. But we're going to fill in A, and we're going to fill in D, and then we're going to do some math and clean it up. So in this case, that would give me Tn equals -9, because that's my first term or my A value, plus n minus 1 times 3, because that's my common difference, and it's multiplication between the n minus 1 and the D. I'm going to send the 3 into the bracket to get 3n minus 3, and then I'm going to collect like terms. So my final rule is -12 plus 3n, or 3n minus 12 if you didn't want to lead with a negative and rewrite it. Because now I could generate the terms of this sequence by subbing in 1, 2, 3. 3 times 1 subtract 12 gives me -9. That's the first term. 3 times 2 minus 12 gives me -6. That's the second term. 3 times 3 subtract 12 gives me -3, and so on. So now if I wanted term 100, there's no need for me to generate all the terms. Term 100 would simply be 3 times 100 minus 12. So that's going to be 300 minus 12, which is 288. So that's what the general rule is for. Don't leave it like this. We always clean it up by multiplying in. This only works, though, if the pattern is arithmetic. If I look at B and I do a common difference, then I don't get the same answer, because the first one is 11, then the next one is 22, then the next one is going to be 44. So those differences are not the same. So this isn't arithmetic. But another thing I can do, so that was by backward subtracting. You can also divide. So if I do 22 divided by 11, I get 2. If I do 44 divided by 22, I get 2. If I do 88 divided by 44, I get 2. So for arithmetic, you have to subtract and find a common difference. If that doesn't work, try dividing, because if you divide and you get a common ratio, then it's geometric. So in this case, this is going to be geometric. My common ratio is 2. My first term is still always a, which is the first number in the list. So I have r equal to 2 and a equal to 11. The formula for arithmetic is Tn equals a plus n minus 1d. We have a different formula for geometric. So for geometric, the formula is going to be Tn equals a times r to the n minus 1. So in this case, I'd have Tn equals a is 11 times 2 to the n minus 1. Now that's all you can do. This is not equal to 22 times n minus 1. You cannot multiply a and r together if they're different, because BEDMAS, or order of operations, says we would have to do the exponent first. So do not multiply your a and your r together. That's our final general term. So now if I wanted term 8 for this one, I could just go into my formula. That's going to be 11 times 2 to the 8 minus 1. I figure out my exponent first, which is going to be 7. And then I do in my calculator 2 to the exponent 7. And then multiply it by 11. So the answer is 1,408. So these formulas will always be the same. If it's arithmetic, you sub into this formula. If it's geometric, you sub into this formula. Patterns, adding or subtracting, it's arithmetic. If it's multiplying or dividing, it's geometric. I'm going to do where it's subtracting or dividing. So I'm going to start with 15, 10, 5, 0, etc. So again, these ones are going down 5. So my common difference, if I subtract, is going to give me negative 5. That way I know that it's arithmetic, so I can write my formula down. Here I really need to be careful though. When I put in my d, I can't just go minus 5 at the end. I have to put it in brackets. So there's my a value, always the first term. D is what's happening, going up 5, down 5, or the number you get when you backwards subtract all of your sets of terms. And then I just sub in. So it's going to be 15 plus n minus 1 times negative 5. I'm going to send the negative 5 into the bracket. So then my formula for this one would be 20 minus 5 times n. The next one, 81, 27, 4, 3, 1. If I look at this, I'm dividing by 3, or if you do your backwards division, so in this one we subtracted, this one we divide, you're going to get 1/3 or 0.3 repeated in your calculator. But if you get the same number each time you do that, that is going to be your common ratio. And that's how I know it's geometric. So r is actually 1/3 in this case because I'm going down, or 0.3, but I'm going to work with the fraction because it's exact. And a is 81. So Tn is going to be 81 times 1/3 to the n minus 1. And again, I'm not going to multiply those together because of order of operations. Now, we can start to use this to find the how many terms are in a sequence. So if I have an arithmetic pattern that goes 3, 5, 27, a bunch of terms in the middle, and ends with the last term of 495, if I want to figure out how many terms there are in this list, it's not 495, that's my actual last term. So what I'm going to do is I'm going to first figure out that it is arithmetic. So if I look at what I'm adding 12 between terms, so that's my D. A is 3. So I can use my formula, a plus n minus 1 d, for arithmetic patterns to generate a common term. And I'm going to simplify it by sending the 12 into the bracket. And my formula is -9 plus 12n, or 12n minus 9. Either of these is fine as long as you multiply in and simplify. But now what they're asking us is Tn is 495. What n goes with that term? Because that'll tell us if this is the 20th term, the 50th term, that's how many terms there are. So because my formula is Tn equals 12n minus 9, I'm going to put the 495 in for the Tn. And now I'm going to solve. So the first thing I'm going to do is add 9 to both sides, or bring the 9 over and add it. So that's going to give me 504. And then I'm going to divide by 12 to get 42. So there are 42 terms in the sequence. When I'm solving for n, I have to remember that n is an ordinal, meaning that it's a whole number. It can't take on 0, negatives, or decimals, or fractional values. So if I got a weird n here, I know that I probably had done something wrong. But by solving the n that goes with the term, you are figuring out how many there are. So what I would like you to look at, starting today, and we're going to work on these and talk about them tomorrow, is on page, just want to make sure I get the page number right, 47. Look at questions. Now I lost my other sheet. One, 2, 3, 5, 7, and 11. Now there are lots in those questions. There's multiple A, B, C's in each. I want you to do at least 2 out of each question. And then on page 57, I want you to look at 1, 2, 3, 5, 6, and 7. And again, there are multiple questions in each part. I want you to do at least 2 from each of those. Tomorrow in class on Friday, I'll be going over any questions and we'll take a look at this, and if we need to take a day to do work on it, we'll work on it. If we're ready to move forward, we'll go forward from there.